Hello. So last time we laid out that table with the six different things you could find. I summarized directions basically as analytically finding lots of stuff. So it'd be those things we looked at: maximums and minimums, increasing, decreasing, inflection points, concave up and concave down. When you look at the directions, like in your book, a lot of time it will list. I think increasing and decreasing are part A and B. Concave up and concave down are part C and D, and then the maximums and inflection points are the last parts, but you probably need to find those maximums, minimums before you can find the increase, decreases. So you don't have to necessarily do them in the order they listed in. You probably jump to, I believe it's part E when you're looking at most of those assignments. So I'm going to jump in here, get going. This is going to be maybe a little bit more time consuming because we are finding like six different things. Nothing is hopefully too difficult. But we do need to find all of the derivative and when it's equal to zero, positive and negative, the second derivative when it's equal to zero, and positive and negative. So I'll start with the derivative. I'm going to do everything deal with my derivative here in red just to color code things, make it a little bit nicer, hopefully. So if I take the derivative of 2x to the fourth minus 4x squared plus 1, maybe I'll let you do that. What would be the derivative of 2x to the fourth minus 4x squared plus 1? Yeah, so 4 times 2, that's going to give me 8, and then I subtract 1, so x cubed. 4 times 2 is again going to give me 8, and I subtract 1, so it's just x. And the derivative of 1 is just 0. So when I'm looking at finding critical points, those maximums and minimums, I'm setting this derivative equal to 0. And if I look at this, I've got x cubed, so that's a little bit more complicated, but I notice they both have an 8, and they both have an x. So what I'd want to do on this is factor out 8x. And what's left would be x squared minus 1. So doing a little bit of factoring, de-distributing whatever they have in common. And that's still equal to 0. So that would give me that 8x equals 0, and that x squared minus 1 equals 0. And if I add 1 over and take the square root of both of those, I would get x equals positive and negative 1. If I divide by 8, I get x equals 0. So I got three values: 0, positive 1, negative 1. Now, the next thing we'd done when we're dealing with just our critical values and our increasing and decreasing was I set these up on a number line. So I'm going to do that again. Set up on my number line. I'll be looking at in numerical order. I've got negative 1 and 0 and 1. And one thing that sometimes is maybe helpful, I'm going to just like circle these just to indicate that these are the special values that I'm looking at. I'm looking in between these sections here. So that gives me 4 sections over here, in here, in here, and in here. And I'm going to look at the value of the derivative. I want to know if that derivative is positive, meaning it's increasing in this section, or if that derivative is negative, meaning it's decreasing. So I'm going to pick some value that's less than negative 1, probably negative 2. I have to pick some value that's in between negative 1 and 0. Unfortunately, there's no nice integer numbers in between there. There's not necessarily a great way, but I'm going to go with just negative 1/2. And then over here, I'll do a positive 1/2. And for my last one, I'll do that derivative at 2. So I've got a little bit maybe a symmetry, negative 2 and 2, negative 1/2 and 1/2. And I'm plugging those into the derivative. Now, something that could potentially save me a little bit of time, and you can confirm this if you like. If I look at this derivative, 8x cubed minus 8x, I'll notice that the exponent of this term is 3, which is an odd number. And the exponent of this term is 1, which is also an odd number. So both my terms have an odd exponent, and that means it's going to be, this is an odd function. That's sort of that origin of that odd and even. Why are they called odd? Why are they called even? Because when you're looking at polynomials, if every term has an odd exponent, then it will be an odd function. If every term has an even exponent, it will be an even function. So knowing that, then if I figure out what negative 2 is, positive 2 is going to be the exact opposite. Same number, just the different side. Same thing with negative 1/2 and positive 1/2. So I can save myself a little bit of time and just do negative 2 and maybe negative 1/2, or I can do positive 2 and positive 1/2. Maybe I'll do positive 2. Just positive 2 sounds a little bit easier. So I'd be plugging in 8, 2 cubed, minus 8 times 2. 2 cubed, 2 times 2 times 2 is 8, times 8 is 64. 8 times 2 is 16. So that's going to be a positive. Doesn't even really matter what it is. It looks like it's 48. but it's positive. That's what we're interested in. And if I plug in the -2, I'm going to get the exact opposite. I'll get -48. So it's going to be negative because it's an odd function. And you can plug in -2 pretty easily and get that. If I do 1/2, let's say I do -1/2. That's just for fun. -1/2 cubed minus 8 times -1/2. So if I do -1 cubed, -1 times -1 times -1 is -1/8 times 8 is -1. And -8 times -1/2 is going to be positive and be 4. So I'd get a positive number here. And then over here, I'm going to get the exact opposite. This was 3. This will give me -3 if I work it out because of that odd function part. Okay, so I've got some information here. And frequently we'll see, as you set up your number line and you work through sections, this alternating negative, positive, negative, positive. It does not always work out that way. As you recall, we did talk about a graph where like it sort of increases, the slope goes to 0, and then it starts increasing again. So you might get like back-to-back increasing or back-to-back decreasing sections, but oftentimes you'll get an alternating pattern if it's just sort of a normal maximums and minimums and stuff. Okay, anyway, I'm going to get going here. I've got A is when it's increasing when you look at your assignments. So I'm looking at increasing. That is this part right here. And I circled these -1, 0, and 1, so I'm going to be using those. So if I, between -1 and 0, I could write that as -1 is less than x is less than 0. And then it's also over here in this far right section where you go from 1 and beyond. So that would be when x is greater than 1. For decreasing then, looking at decreasing is going to be this leftmost section on my number line and this section here. So what would that give us for our decreasing? What would be the correct way of writing that for if it's to the left of -1 and if it's between 0 and +1? What would be our decreasing? So we should get that x is less than -1 and then between 0 and 1. And our last part, I believe it's part E on the assignment will be extreme. And that would be dealing with the -1, the 0, and the 1. And if I want to figure those out, just thinking about my graph, it's decreasing, and then it increases, and then it gets to this point and starts decreasing, and then it's going to get to here, and then it's going to increase. So these are minimums, -1 and +1, and the 0 is going to be a maximum. So I'm going to have, let's plug in the max first. And max when I do x is 0. And if I want to figure that out, I'd look at the original graph now, original function, plugging in 0 here. So I'd have 2 times 0, 0, minus 0, plus 1. So that's just going to be 1. That one's pretty easy. There we go. And then we're going to have some minimums. And that's going to be a -1 and a +1. And if I do look back at my original graph there, again, original equation, one thing I talked about how, that's an odd exponent, that's an odd exponent. These are even exponents. I got to the 4th, to the 2nd, to the 0, and 0 is an even number. So they're all even exponents, and that means that this is an even function, which makes our life a little bit easier. If I plug in 1 and -1, I will get the exact same answer in both of those, and you can check it out if you want. But I'm just going to plug in 1 then. So 1 to the 4th and 1 to the 2nd, those are both just 1. So 2 minus 4 plus 1. 2 minus 4 plus 1 gives us, I believe, a -1 last time I checked. And if we plug in a -1 or a +1, both of those, we would get -1. So -1 and -1. Okay, so those are 3 of my answers so far, A, B, and E. We're over halfway done, don't worry. The next part, I'm going to switch to a blue pen, just to change it up a little bit. And we're going to be looking now at our second derivative and doing the same process with the second derivative, setting it equal to 0 and figuring out with a number line positive and negative. One thing you'll see as you do a couple of these examples is typically like here, if we have 3 values when we do that first derivative, we'll probably have less typically, either the same amount at most or less values we'll have to consider when we do that second derivative. So I'm going to do a second derivative. It's 8x cubed minus 8x. What would be the second derivative? The derivative of this? The derivative of 8x cubed minus 8x. Okay, so we got 24 x squared. If I do that second derivative, because it was 8 times 3, so 24x squared, and then 8x, the derivative of that would be minus 8. And just like before, we're setting that equal to 0. I could factor out an 8 out of both of these, similar to what we did before. And if I do that, I got 3x squared minus 1. If I divide by 0, then divide by 8, then that's gone. So I'm really just looking at 3x squared. I add that over equals 1. X squared equals 1/3. And I'd be taking a square root. So x is going to be a positive or negative. Square root of 1 is 1 over the square root of 3. And if we want to, we could rewrite that in our proper form. You're not supposed to have a square root on the bottom. So that'd be a square root of 3 over 3. It would be the, I guess, nicer way of writing it. So we just have two values now when I am going to set up my number line. Instead of 3 like I did last time. So if I set up my number line here, I've got a negative square root of 3 over 3 and a positive square root of 3 over 3. And again, maybe just to keep track of things, I'm going to circle those. Those are my key values. And a similar process to what we did before. Before I picked out a number in each of these sections and plugged it into the derivative to find out if it's increasing or decreasing. Doing the same thing, just with the second derivative. So I'm going to plug into my second derivative a number that's less than negative square root of 3 over 3. And if you typed into your calculator 1 over the square root of 3 or square root of 3 over 3, you get like, I think it's like 0.707, maybe, I can't remember exactly. It's less than 1. I know that. I'm going to plug in negative 1. And if I, in the middle here, I can plug in 0. That's going to be by far the easiest one. And then over here, I'm going to plug in a positive 1. And I can notice when I look at my second derivative again, I got x squared. That's even. X to the 0 would be here. That's also even. So this is another even function. So whatever I plug in for negative 1 or positive 1, I get the same number. I don't have to do it twice. I'll just get the same number. So if I do the negative 1, let's say 24 to the negative 1 squared minus 8, that's just 1. 24 minus 8, that's positive number. It's going to be 16, it looks like. And if I plugged in 1, I'd also get 16, exact same number. And if I plug in 0, just to close this off, 24 times 0 squared minus 8, that's 0. So that just ends up being negative 8, and that gets a negative 1. And again, most of the time you'll get that alternating pattern. It doesn't always happen, but a lot of time you get a positive, negative, positive. So let's finish this bad boy off, or bad girl. I don't know what the gender of this particular problem might be, or bad it off. I mean, it's neutral. Anyway, part C is going to be concave up. Part D is going to be concave down. And then the last part, F, is our inflection points. So if I start maybe with the inflection points, that's the negative square root of 3 over 3 and the positive square root of 3 over 3. So if I plug those in, and like we said when we were doing this on the first part, I'm plugging those into the original function, like when I did the maximums and minimums. So if I plug into my original function a positive or a negative number, because it was an even function, we get the same thing. And if I did that correctly, you could do it on a calculator. You could do it by hand, work it actually out. You do get negative 0.111111, and you might recognize if you get a repeating decimal like that, those are always ninths. So like a negative 0.111111 is negative 1/9. Nice thing to be aware of, negative 1/9. So you get negative 1/9 for both of them. And if you worked it out by hand, actually squaring things and you would get all things through the thirds or ninths, and you'd be able to work it out. So we get that. Concave up, that's the positive parts. So similar to when you're doing our increasing and decreasing, anything to the left of negative square root of 3 over 3. So that would be that x is less than negative square root of 3 over 3. And also anything to the right of a positive square root of 3. So x is greater than square root of 3 over 3. And then for concave down, squeezing that in the middle here, that was between the negative square root of 3 over 3, and the positive square root of 3 over 3. Whew. I mean, so these are pretty long questions here. A lot of time, this one's probably a little bit more on the upper end. A lot of time, you probably won't get the 3 minimum, maximum values and 2 inflection point values. A lot of time, you'll probably only get maybe 2 and 1 when you do this. A little bit easier, a little bit less sections you have to be checking. Sometimes you might even get that there really are no extreme values. It might just be an inflection point. There's lots of different varieties of stuff, so you get to experiment a little bit with that. Your homework assignment is just going to have 3 questions, so that's not too difficult, hopefully. So I'll let you get going on that. As always, if you're getting stuck on things, you should know where to find me. Feel free to contact me. Sorry if this video was a little bit long, but I'm sure it was an enjoyable experience as we went along. So thank you.